When you start IBM SPSS Modeler, you'll be at this screen here. The first thing that you want is you want to get a data source. So you would go down here at data source, and you have several different selections here. If you're using a CSV file, then you would use this var file, variable sized file. You could also use Excel, and this is what we'll be using for the most part in this class. So we can either drag and drop it, or we can just double click it and it will show up. So I have a couple data sets that you can find on Icon, and you'll need that for this example. So I'm going to double click this, and here's asking us Excel 97 to 2003 or the 2007-2010, and notice here the extension. The files that I have are in 2010 version, so I'm going to select that. Then I'm going to import the file, so I'm going to go find it, and here it is. I'm going to use the mortgage training. Okay, so now we can preview the data. Okay, and this looks right. So I'm going to say OK, and notice here first row has column names, and that was correct. Okay, also notice here, if you have, this is important to know, if you have the data set, this data set here, and let's say you have it open in Excel, it won't work. So you have to close Excel first, and then you can load the data. So make sure you don't have this mortgage training data set open someplace else, i.e. Excel. Okay, so now the next step here is we'll use this field ops here, operations, and we're going to look at the types, and I'll show you what that is. Okay, so with this we need to give a measurement to our individual attributes, and we need to tell the program which ones we're going to use, and which ones that we're going to use as inputs, and which one we're going to use as an output to predict on. So let's go and read the values. Okay, and this shows the values here. Okay, so this ID here, this is continuous, and this is not something that we would use to predict with. This is just labeling our records, and so you would select this here as record ID. Okay, so now if there's something here that you don't want as an input, then you can just go ahead and unselect it by saying none. But we're going to select everything here as the role, as inputs, and this here, the risk, we're trying to determine whether or not the customers are good risk or bad risks, depending on their attributes. And these attributes are age, income, gender, and whatnot. This is the same data set that we've been using in class, well, from last time. So go here and say risk, it's a target. Okay, so apply, and then OK. Okay, so now we've defined what each one of our attributes are. Okay, so now we can do things such as we can plot it, we can create a histogram with it, and let's just do that for right now. We're going to create a histogram here, and let's just say age. We want to see the distribution of age. And here I just hit play, and this histogram showed up for age. And we can also do things such as adding colors within it depending on, let's say, gender. We can also have a separate panel that would show marital status, so whether or not the individual is single or divorced. We'll have a separate single, married, or divorced. So I'm going to just show you what that looks like. Okay, so we have our three different marital statuses here: divorced, married, and age, or single. And then we have the age, the histograms, and they're colored by sex here, the gender. Okay, so And we have quite a few different graphs that we can do. Another thing that we can play around with here is we also have another choice here called Graph Board. And we can click that here, and this will give us all the different options according to the attributes that we choose and that we want to graph. So let's say we want to look at age. Well, this will tell us all the different plots that are available to us. We can also select, and I'm holding down the control key, and I'm selecting 2 or 3, and this will give us our different options for plotting those. So for example, with 2 you can create a scatter plot here, and so you would just select this here, and then you would run it, and then it would have a scatter plot that would be displayed. So there's quite a few visualizations that you can do within SPSS Modeler, although not nearly as intense as what we were using in Tableau. Okay, so I'm going to close that. Okay, so now let's go to Modeler. And we have this number of different options here for predicting. We're predicting, the attribute that we're predicting here is it's categorical, right? So we're predicting not a number. If it were a number, that would be regression, and we would use regression type formulas like simple linear regression. But what we're doing here is this is a categorical. This we would need a classifier. We're going to classify whether or not somebody is a good risk or bad risk. So there's a number of different classifiers that we could use. We could use logistic regression. We could use decision trees, artificial neural networks, support vector machines. In this case, we're going to use a C 5.0 decision tree. So here I'm going to either drag and drop it, or I can just double click it and it will go to the right place. And notice here that it says here at the bottom risk. Now remember here from our type, we automatically selected our target as risk. So that's what's displaying here at the bottom right. Okay, so now what we're going to do here is we're going to play it. It's thinking, it's creating the model, and then we had this little diamond, diamond in the rough here is what we've just created, and this is the built model. So this model here has been built. Now we built it with the training data, and now of course we can look at the results, but the results aren't going to be very fair to look at because we normally wouldn't test the model with the data that we just trained with. That's just not very fair. So what we're going to do here is we're going to add another Excel document here. Oops. Make sure it's 2007, 2010. And I'm going to say testing. Now this data set here, this is in the exact same format, same rows, not the same rows, but the same columns as we had in the training data set. So what I'm going to do here is I'm going to replace this training data set. I'm going to instead select the testing data set and add it to type, and then we're going to run the model through the type. It's going to get the same types as what we had before, and then we're going to go through the model that's already been built, the model that was built through the training data set, and then we're going to output some results. Another thing that we're not going to need anymore is we're not going to need this C 5.0 tree because we've already have the built one. So I'm going to go ahead and delete that. And now I'm going to select this, and I'm going to hit F2, and I'm going to go to type. And it's going to ask us what we want to do, and I'm just going to say replace. So this is fine where it is. I'm just going to keep it over here. So now what we're doing is testing data set, going to the same type as what we had before, and it's now going through the built model that we built through the training data set. Okay, now we need to output it. So we need to output some analysis. Okay, and I'm going to output some analysis, and here it is. So with our decision tree, we are 85% correct as far as accuracy is being shown here. 14%, 14.8% is incorrectly classified by the decision tree. We can also go over here and we can browse the decision tree, and we can just see what predictors, what attributes are most important when building that model. So what we show here is we show the number of outstanding loans is most important, followed by income, and then store cards is not really all that important. We can also look at the decision tree that was built, and this is the decision tree. It's a pretty simple decision tree here. So we start with risk, and so what we show here is we show that 82% are bad risk. 82.6% are bad risk, and 17.391 are good risk. And then you go down the number of outstanding loans. So anything that is, if the individual has no loans, well, then you have a much greater probability that that person is going to be a good risk than if that person has more than one, or more than, well, if the person has one or more loans. And then we go down here even further, and now it's broken up by income, and it looks like individuals with less income are actually better risk, according to this model, than those with than greater income. Interesting. Okay, so let's get out of that. Now, if you noticed here, when we ran this model, it showed that we are correct 85% of the time. And this is something we're going to talk about further in the class, is that this is not really all that good, because if we would have just always predicted that we were bad risk, well, we would have correctly we would have been correct 82.6% of the time, correct? Because that's what the decision tree showed over here, that bad risk made up 82%. So all we had to do is just always predict that somebody was a bad risk, and we would still get 82.6%. We're going to talk about that more in the class. We can also look here at a confusion matrix, and so I just double-clicked on matrix, clicked on it here. I'm going to look at risk, and I'm going to look at the predicted risk. And the predicted risk is, or the prediction according to the model is always going to have this $sign next to it. I'm going to run that. Okay, and this gives us our confusion matrix. So this is what's being predicted, and this is what is actual. Okay, so in other words, good risk was correctly identified by the model 32 times, and when the model predicted that it was a good risk, but it was actually a bad risk, it actually did that 25 times. So that's it for now. I'm going to talk more about this in class. Thanks.